Okay, guys, here we go. I wanted to go over the problems that we didn't quite get a chance to go over in depth during class today. So let's go ahead and look at number 9. I can't remember. Some of you had an answer, and I don't think a lot of them were right. So let's go ahead and we'll start with number 9 on the back side of your paper. Okay, so it's asking what is the value of x in this equation. So x is going to be one number, okay, and it may end up being where it has no solutions, and that's what we're going to figure out. So let's go ahead and work this out. First thing we notice is we can distribute right here. 3/2 times 4x, and 3/2 times a -1. Remember, we kind of sort it right here, so we know that negative goes with the 1. So when we're multiplying a positive times a negative. All right, so 3/2 times a positive 4x is going to be 12x over 2. And a positive 3/2 times a -1 is going to be a -3/2 minus 3x, right? So I'm just going to keep that here. And then on this side, we're going to have 5/4. And we're going to distribute here. I think I've covered this with you guys before. If you have a negative sign, if you have a negative sign outside parentheses, like you do over here with the negative times x plus 2, it's as though there is an invisible 1 in there. That negative sign can be attached to a 1, making it a -1, so that when I do my multiplication here, I'm going to have a negative x, and then a -1 times a positive 2 is going to give me a -2 or -2. So there's what we have in our first step. Let's go ahead and write that down. Taking a look at it, 12 over 2x is going to give us 6x minus, and I'm going to put this 3x right here. I'm going to put it next to the 6x because we're going to combine that in just a moment. Minus 3/2 equals 5/4 minus x minus 2. Now I notice I have an x on this side of the equation, and I've got my 2x's over here, so I'm going to work to combine those. So I'm going to add an x to this side. I'm going to add an x to this side. Before I actually write that, let's go ahead and make this combination. Whoops. Oh, for heaven's sakes. Undo, undo. There we go. Let's go ahead and I just want to get rid of that. There we go. This is going to be 3x, and I'm adding this x right here. Remember, I'm going to add that to this side also. So now on this side, I'm going to have 4x minus 3/2 equals 5/4, and these canceled out, minus 2. All right, now I am going to, let's see here. I'm going to change this 3/2 right here. I'm going to change that to 6/4 so that I can have the same denominator as I have on the right-hand side with 5/4. So then I would have 4x minus 6/4 equals 5/4 minus 2. And then I'm going to add the 6/4 to both sides because remember, I'm trying to isolate x, so I'm trying to remove anything that's in the way of doing that. So now I have 4x left on this side, and I have 11/4 minus 2, which, by the way, I'm going to call that 8/4 right here. It's the same as 2, but that way I'll be able to do the math here. Okay, I'm going to go up here now and finish up. Okay, so I have 4x equals 11/4 minus 8/4. I have 4x equals 3/4. And now, so a couple ways I can look at this. I would want to divide by 4 because that would make my x be a 1x, right? But I don't really want the messiness of dividing by 4 on this side. So remember we talked about anytime that we can do a division, it's the same as doing a multiplication of the reciprocal. So what is 4? As a fraction, I'm going to make it 4/1. That way, I can multiply by 1/4 on both sides. That will take care of that because 4/4 is 1. So I have 1x or just x. And on this side, I have 3/16. So that's the answer to number 9. Okay, we did number 10 in class. We did 11 and 12 in class. Let's take a look at 13. I don't think we did that one. So I notice here I have an inequality. I have something on the left-hand side that looks like I can distribute right away. So that's what I'm going to do to start this problem. I'm going to take 3 times x which is 3x, and 3 times a negative 2 is a negative 6. So I have 3x minus 6 plus 1 is greater than or equal to x plus, and I'm going to distribute here as well. So I'm going to have 2x plus 4. Okay, so now I'm looking to combine like terms. So what do I notice? I have a 3x here. I have a couple of x terms over here. And then I'm going to highlight in a different color here. I'll take orange. I have all these integers here. They're non-x terms. Those can be combined as well. So let's combine these a little at a time. So I have 3x minus 5 is greater than or equal to 3x plus 4. Okay, I can kind of see where this is going already. So I'm going to move my 3x by subtracting it off both sides, and look what happens here. They cancel out. So what am I left with here? Negative 5 is greater than or equal to 4. Is that true? Negative 5 is less than 4. So this is a false statement, which means there are no solutions to this equation. It doesn't matter what I can put in there for x. Up here, if I were to put anything in for all these x terms, let me highlight this so you can see what I'm talking about. If I wanted to put something in for each one of these x's, the same number, because x can only be the same value at the same time. So if I were to put 3 in for x throughout that equation, it would not actually make it would not make a true statement. So therefore, it doesn't matter if I put a 3, if I put a negative 3, if I put a 20, it doesn't matter what I assign to x, it will not work out and make a true statement. So there are no solutions for number 13 simply because, and you look at that and you go, but how do you know that, Mrs. Quigley? Because that is false. So if it turns up to be false, there's no solutions. Let's look at number 14. Number 14, we're going to graph the solution of this inequality. 2x minus the quantity of 3 minus x is greater than x plus 1, and then we're going to put it on the number line. So we have to do a little solving here first. So let's go ahead and work on that. All right, so I'm going to rewrite I think I can work it out right over here. All right, so I've got 2x, and look here, I'm going to do some distributing here. And what did I say a few minutes ago in another problem? I said when you have a negative sign that's being multiplied with a quantity that's in parentheses like this, we have to act as though this is actually acting as a negative 1. Okay, so the negative sign is actually what's being multiplied here. And so let's work that out. So I have 2x minus 3 plus x, because I have a negative 1 times a negative x, gives me a positive 1x, or just positive x, or plus x. And on this side, I have x plus 1. Okay, so we just keep working this out to get our x terms together, which I see right here. I have a 2x, and I have a plus 2x over here. I don't like that covered up everything, so we're going to just underline them instead. So I have 2x plus x. I'm going to have a 3x minus 3 on the left-hand side and x plus 1 over here. Whoops. Greater than. Oops, minus 3. Trying to figure out what I erased here. Oh, gracious day. All right, so I have 3x minus 3. There we go. All right, now what is next? Remember, I'm trying to isolate x, but I look like I still need to get a couple x terms together. So I'm going to subtract the x from the right-hand side and subtract it from the left-hand side so that I can eliminate it on the right-hand side and bring them together on the left. So now I have 2x minus 3 is greater than 1. Let's get this 3 over here. Now I have 2x is greater than 4. I'm going to divide by a positive 2, so my sign is not going to flip. I have x is greater than 2. Okay, so there's the solution for this, so we need to figure out how to graph this. So I am going to put a red pen to this, and we're going to find 2, and I said that x is greater than that 2. So that's what your graph should look like right there. X is greater than 2. All right, let's go look at number 15. Solve the compound inequality. 2x plus 5 is greater than negative 3. And notice 4x plus 7 is less than 15. Okay, so this already tells us that this is an and compound inequality. But we're going to work to solving this out first. I'm going to look at the first equation on the left here, and I'm going to first subtract 5 from both sides because I'm trying to isolate x. and I'm going to divide by 2, and I have x is greater than negative 4. So there's my first solution, and we're going to have another one. We're going to go up here and subtract 7 from both sides. I have 4x is less than 8. I divide both sides by 4, and I end up with x is less than 2. Okay, now this is an and that should tell you something about the graph that you're about to put down here. Let me change this to black. Here's my graph. I'm going to start at negative 4. I'm going to put a 0 in the middle, and I'm going to go to 4. And we're going to put negative 2 and 2. We'll just skip count by 2s, and that'll give us the numbers that we need. Let me grab a red pen. All right, so I have x is greater than negative 4. Open circle, because it's not equal to, it does not include negative 4. And then x is less than 2. So we have an open circle there too. Now the and tells us that I should have a combined shared points with my graph. It should show points that are shared with both of those solutions. So then we would just show those points that are in between those two values for x. Okay, but you should already be evaluating in your head when you see the word and. You should already be evaluating what your graph is going to look like, because and means that there are going to be some shared points there, remember, or means they're going in opposite directions. They're not sharing points. But when you see and, that means that they are. Okay, so now let's look at number 16. Number 16, now notice the graph here. I couldn't get my circles to be nice and round. I was having a hard time with that. Okay, but let's look at the graph here. So I have x is in between. If you notice here, x is in between these 2 points right here, right? Let's kind of put little squiggly lines there. All the values in between that. It is an overlapping of points. So it's an and compound inequality. So how is this? This is a negative 5 down here. So x, if I'm going to write 2 separate inequalities to represent this graph, and then I'm going to show you how we can write one long compound inequality. And both are correct. It doesn't really matter unless you were asked to do one or the other. But let's figure out with relationship to negative 5, where is x? Because negative 5 is actually less than, isn't it? Negative 5, let's see. Negative 5 is less than x because x is up in here. So it's greater than negative 5, which means that negative 5 is less than or equal to x. So I can flip that around and say x is greater than or equal to negative 5. In fact, I'm going to go ahead and just get rid of this one because we don't really need that one. Excuse me. And the other one, you notice that x is less than or equal to negative 1. Okay, now when I graph this thing, it should show an and compound inequality. It should be sharing points. So here's 0 in the middle, negative 5 is down here, and negative 1 is here. Grab my red pen. We're going to place some, oh, gracious day, it's already been graphed for you. What am I saying? Sorry about that, guys. I get so excited about these, I want to graph it again, but it's already graphed for us here. That was the whole point. We're trying to write compound inequality for that graph. Now, how can I take these and write one long compound inequality? Well, I'm going to take the x, I'm going to put it in the middle, okay? Because notice x is in the middle of these points, right? So x, how does it look? Okay, well, negative 5 is going to go here, and negative 1 is going to go here, just like you see on the graph. Okay, so where is x in relationship to negative 5? Or where is negative 5 in relationship to x? It is less than x, isn't it? Because x is beyond it this way. So negative 5 would be less than or equal to x. And actually, this one is already written for us. So we just stick that right in there. So either, it doesn't matter if you write it this way or you choose to write them one of those ways. They're all correct. That's number 16. Number 17. All right, the area A, they're calling the area that by a capital letter A of the rectangle shown is described with the inequality 35 is greater than or equal to A, or the area, which is greater than or equal to 25. We want to write and solve a compound inequality for x. I would have liked to have seen how you guys would have handled this one. Whoa, goodness gracious. It's really not as difficult as you may think. So I'm going to rewrite this 35 is greater than or equal to A is greater than or equal to 25. Now, I am told that the area of the rectangle is represented by this large A in the middle here. Okay, so what is the area of this? I have a 5 and I have an X. How would I find the area? Well, area would equal 5 times X, right? Or just 5X. So area is equal to 5X. So we're going to substitute that right here for area. And we're going to rewrite the rest of the compound inequality. And I look at all three numbers and I try to evaluate how can I simplify this to get this to isolate X, because that would be our goal here, right? Would be to isolate X. Well, I would divide by 5. But if I'm going to divide by 5 there, I have to keep it in balance and divide all of my terms by 5. 35 divided by 5 is 7, is greater than or equal to X, is greater than or equal to 5. And that is the answer to this problem. Number 18, solve the absolute value equation. X minus 4 equals 9. All right, so I'm going to make two little mini equations. This is what we talked about last week. Well, I have to think to myself, first of all, what can be inside here? What would it be if it was just this? Would you know what to put inside there? You should tell me, well, it can either be a 9 or it could be a negative 9. Right? Because remember, absolute value simply means the distance away from 0. So a negative 9 is the same distance from 0 as a positive 9 is, right? They're both 9 steps away from 0. So your absolute value on the inside there can be a negative and or a positive. Okay? So in that case, think about it. This has to equal either 9 or it has to equal negative 9. So I'm going to make two little mini equations. I'm going to pull them outside here. I'm going to do one here and one over here. And I'm going to say X minus 4, which is on the inside, has to be equal to 9, or X minus 4 has to be equal to negative 9. Once I figure those out, then X should satisfy my equation up there. So let's figure out our solutions. Okay, so I have X equals 13. And we're going to check that in just a minute, see if it's really true. And I have X equals negative 5. Now I'm going to plug those back in up here. Let me erase what I wrote up here, and let's put that in. So if I put 13 in here, 13 minus 4, that's what I said the first X was, right? 13 minus 4 is 9. Well, we said it could be a positive 9. Now let's try the other solution we got, which is a negative 5. Negative 5 minus 4 is a negative 9. And we said it could be the absolute value of negative 9 is also equal to 9. So therefore, we have figured out two solutions that will satisfy this absolute value equation, and those both work. So you have both solutions. So please always make sure you're listing both of those, X equals 13 and X equals negative 5. Okay, we did number 19 in class, so I'm not going to take time to do that now. If you have questions on that, you could get with a classmate, or if you want to send me an email, I can work with you this evening. If you have time, I can do a Zoom call with you. But let's go ahead. But I did do it in class, so I'm not going to take the time to do it here. Number 20, graph the solution of the absolute value inequality on the number line. Okay, so I have a long inequality here. I have negative 2 times the absolute value of 2x plus 4 plus 10 is greater than negative 6. So the first thing we have to do is isolate this thing for x. So let's work toward doing that. The first thing we need to do is subtract 10 from both sides. And always copy down what's left. Do not shortcut this in algebra. You will be sorry. Please make sure you're always copying down your steps. From here, I'm going to divide by a negative 2 because I have a multiplication of negative 2. So to undo the multiplication, I have to divide it. I still have my absolute value of 2x plus 4 is greater than negative 16 divided by negative 2 is a, hopefully you caught me right there. Keep in mind, what did I divide by? I divided by a negative right here. And remember, when I divide by negative 2, I must flip my sign. Because I just changed my negative number, negative 16, now became a positive number. So my sign has to automatically know to flip. Okay, so now I have 2x plus 4 is less than 8. All right, so the question is, first of all, I have to think about what could be in here to have the absolute value of 8. Remember, it can be 8 or it can be negative 8. So I have to make two little mini equations. I'm going to make 2x plus 4 and set it equal to 8 because I know it can become 8 inside there. Or it can be a negative 8. So 2x plus 4 could be a negative 8. So let's work these out. Oops, and I should not put equals because that is not what this problem is. This problem is an inequality. So we have to keep that going. It's less than 8 or less than negative 8. Sorry about that. All right, so let's keep going. So let's subtract 4 from both sides. Remember, if we subtract a negative, that's okay. It's only when the sign gets changed because of a division or multiplication of a negative number. All right, so now I have 4 over here. We're going to continue this by dividing by 2, and I will have x is less than 2. There's one of my solutions. Let's try the other one on our other little mini equation over here. So I'm going to subtract 4 from both sides. I have 2x is less than a negative 12 divided by 2. X is less than negative 6. Oh, wait a minute. What did I do here? Why is that flipped over? Greater than. Why do I have a greater than? Oh, wait, and. Oh, okay. Whoopsie. I'm sorry, I'm a little rusty-crusty from last week. I haven't actually looked at these again. So, all right, hang on. I need to go back up here and ask myself, in the problem, right here where this got switched around, I now have to look at this and think, okay, remember the little trick I gave you the other day? I said, remember there's go LA. What does that mean? If it's greater than, it's or. If it's less than, it's and. Remember that? Well, this one happens to be less than, so we know it's going to be an and, which means that my on my number line, there are going to be some shared points in there. So my sign here is going to actually flip at this point on this little mini equation. So 2x is greater than negative 12. Excuse me. We divide by 2. X is greater than negative 6. And that's my other solution. So let's go ahead and we're going to graph these. So I have x is less than 2. Let me use red. I always like to use red here. X is less than 2. And x is greater than negative 6. So my points, all my solutions for this inequality land in between negative 6 and 2. I can't have any solutions outside of that to make this statement true. Okay, so here's my solutions, and here they are graphed. And that's the answer to that. And remember, because it's and, there will be shared points there. Okay, so that sums it up for the review sheet. Please study for your tests. Review sheets must be complete and correct in order to get a good grade on those. For Thursday, if you have any questions, please don't hesitate to email me, reach out to me somehow. I'm happy to help you if you should need anything. Okay, guys, I'm about to put 1-7 on as well, so be on the lookout for that video too. Thanks so much for watching.